We are going to show you the transmitter working. In this case, we will be connected with a computer because this is something that can be done anywhere through a modem, and we can watch online what happens at the radio station. First of all, I will describe the parameters that are of real interest so we can go forward while the test is performed. Let's look at this screen. It will provide a general view of the plant. And as you can see here, this is the segment of the internal temperatures of the equipment. These are the temperatures of the RF modules, of each MOSFET. These are the temperatures of the power supplies, of the sources. The one I am pointing out is the room temperature detected by the transmitter, which is in charge of calculating the air that enters. This measure we see here is very important because it is the speed of the fans. The plant will optimize such speed according to the temperature, so we should always take into account this parameter. Another issue. We will get to know which of the transmitters output power in this segment of the screen, which is where the power and the efficiency are. And here you can see all the voltages. Now we will start the transmitter. And proceed to analyze the behavior of the plant in a normal environment, that is to say, with an air supply. The first thing we notice is that when we turn the equipment on, the fans also start at 100% and will always do so. It immediately starts to check the temperature of the power sources and of the radio frequency area. We'll see now how in a few minutes the fans will be working at a speed that is too fast considering the actual room temperature. You will notice how the transmitter detects this speed excess and slows it down. While this takes place, let me explain some other contents on the screen, like here. For instance, here we determine the temperature of each MOSFET. This is a difficult measure because I have to watch them all. But here, we have a single line representing an average of all the temperatures, and it indicates which is the highest. Simply this way, it is not necessary to look at all of these. Just looking at the highest temperature within the RF is enough. The same happens with the source. Here we see all the temperatures of all the sources, and we can precisely tell which is the hottest. You do not need to examine the temperature source by source. You only need to look here. Some time has passed already, and we can see that the fan speed is slower. They started at 100%, but given the actual room temperature in this case, it was too much. So they started to decrease to 64, 63, 62, 60%. In other words, if a transmitter is installed in a radio station with the room temperature we have here, the fans will work at 60%. And it is logical to assume that this would considerably extend the life of the fans. Imagine the engine of a car working continuously at 100% or at 60%. Undoubtedly, by working at 60%, it will last longer. The estimated lifetime we have for these power sources is over 10 years. But we cannot guarantee that because we have barely been manufacturing this transmitter for 5 years. However, not one single fan has been damaged so far. That is to say, the projection is true so far. Evidently, it will be able to comply with this if the radio station has good environmental conditions and an effective cooling system, because we can see how the fan increases its speed as the room temperature increases, trying to compensate. Let's cover the transmitter now so you can appreciate how the speed increases and how the equipment behaves. Sponsored by 305 Broadcast. Voiceover by Audio Studio.